Don't laugh. Okay, so right, Pippi Bay. So what I'm doing, I'm reading that, and I'm going. The maximum water is that, and the minimum is that. So in other words, I'm sort of got some sort of a, in my head, I've got some sort of trig model where that is 3.5 and that is 1.1.
Yeah.
Happy with that? And so I'm going, okay, then my amplitude must be whatever that distance is. So my amplitude must be whatever that distance is. In other words, 3.5 minus 1.1, but half of it. Does that make sense?
Yep, yep.
So that's 2.4 over 2, therefore my amplitude is 1.2. Happy?
Yep.
And then so what I'm trying to do now is I'm trying to say, okay, so the height of the water is going to be the amplitude. I'm going to use a cos. I'm going to have some sort of frequency within my time, and then I'm going to have a baseline. So that part there, go on there.
Yep.
My baseline is what?
2.4.
No.
2.3.
2.3. It's the maximum minus the amplitude, which is 2.3.
Right.
Does that make sense? Because if the amplitude, which is from the baseline up, is 1.2, or there is 1.2, then 1.1 plus the amplitude must be where your baseline is.
Right.
Or the max minus. So that part there is in there.
Okay.
So at the moment I've got H equals 1.2 cos QT plus 2.3. Happy with how I've got those two numbers?
Yeah.
Now this part here is the tricky one. Do you know why I've chosen cos?
No.
Not really, no.
Because it starts at high tide.
Yeah.
Right.
It starts at high tide.
Right.
You know, like these will generally say high tide is at, low tide here is at 6:15.
Right.
So what I could do is go, okay, so it's low tide, so it's going to be, the low tide is going to be a negative cos, and I'm going to move it over 6.25. Do you sort of understand that?
Yeah.
So I'm matching up my low tide or matching up my high tide. That's why I use cos, because of where it starts on my axis.
Yeah.
Okay. So here, this Q, remember what the QT, what does that stand for? What does the Q stand for?
Frequency.
Yeah, so how many frequencies are there? Now remember, if I asked you to draw cos of 2x, what would the frequency be of that graph?
Half.
No, frequency would be
Pi.
2. The period would be pi. Half of what it normally is.
Right.
Okay, so the period of a normal cos graph is 2 pi, and so whatever that frequency is will turn into your period. So it sort of forms this little equation here. The period of any graph is 2 pi divided by that number there. This is for sines and cosines. Okay.
Okay, yeah.
For tan, that would be, what would it be for tan? Pi over q, yeah. Because the standard tan has just got pi as opposed to 2 pi.
Yeah.
Will they ask us to form an equation for a tan graph?
I might do. Pretty unlikely though, because most, I mean, where you use sine and cosine, that's your standard high tide, low tide type equation.
Yep.
So therefore, if this is my period, and I've got to try and find my frequency.
Yeah.
What's my period for this particular information?
2 pi.
No, because now we're talking about hours.
Oh, right.
So high tide is 6.25 hours after low tide. So how long is what's my period?
12.5.
12.5. Time between two high tides.
Mm-hmm.
So 12.5 is now 2 pi divided by my frequency. Happy with that?
Yeah.
Okay, so now just rearrange that algebraically. That's just the frequency is 2 pi divided by 12.5.
Yeah.
Can't have a decimal and a fraction, so I'm going to double both top and the bottom, which gives me 4 pi over 25. Does that make sense?
Yeah.
So now that there is actually that part there.
Sweet.
Okay, so now my equation is h equals 1.2 cos of 4 pi t over 25 plus 2.3.
You wouldn't simplify that any further to 1.2 cos whatever that equals plus 2.3.
No, because it's because the t's in there.
Okay.
Okay. Now it just so happens. So that's the period. That's my frequency. I don't actually have to shift this one because if high tide is 6.25 hours after low tide, then it's actually 6.25 hours before low tide as well. 6.25 hours before low tide is actually midnight, which is T is time after midnight. So it happens that I don't actually have to shift this. I don't have to have that horizontal translation that you do on the other ones. But the same thing would happen. I'd still do this. I'd still do that exactly the same way. I'd still do that exactly the same way. And then all I'd do afterwards, I'd go, okay, low tide is actually at 4 AM.
Yeah.
So if this said, I'll change the colour so you can, if it said low tide was at 4 AM, all I'd do is I'd still have h equals 1.2 cos 4 pi t over 25 plus 2.3, but all I'd do is I'd match up low tide before. Okay, so what I'd do is I'd say I want to move to the right, so I'm going to go -4, so t -4, so that would match up to low tide, and then I'm going to make it a negative so it matches up with low tide. Because at the moment, if I had that, remember what I'm doing is on this point here is going to move. By moving it to the right 4, I'm moving it like that. By having that negative, I'm actually making it the low tide 4 hours after.
Right. Yep. And do you need to keep it on the y-axis or not? Just.
Oh, so that's more my baseline as opposed to being the x-axis.
Right.
Does that sort of make sense, the process?
Yeah.
It's the same for every single one. Find A, find the baseline, A being the amplitude, B being the baseline, Q being the frequency, and then this part here just sort of comes by moving it, and then if it's a low tide or high tide, that's just a negative or a positive. You know, if it's high tide, it's positive, low tide, negative.
Okay.
Sweet.
Does that make sense?
Yep. Thank you. Perfect.
Alright.